Today we're going to talk about perpendicular bisectors and angle bisectors and how we can use those to solve for missing pieces of triangles. So the first thing is we have two theorems here. The perpendicular bisector theorem says that if a point lies on the perpendicular bisector of a segment is equidistant from the endpoints of the segment, which what that means is that CA is congruent to CB, because this is perpendicular and it's bisecting that segment. So those are the same. And also the converse of that is true, which is if the point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So we're going to use that to answer some questions. The first is there enough information on this diagram to conclude that point N, which is right here, lies on the perpendicular bisector of KM. Okay, so we see that KM is here and it's being bisected, but the answer is no, because we would need to know that these two angles here, angle MLN and KLN, would need to be right angles. If this was here, we could say yes, but since it is not, we cannot. Okay. So we can then use that information, though, if we do know that it is the perpendicular bisector, to solve for missing pieces and parts of triangles. So this one says ZX is the perpendicular bisector of WY, okay, and it says that YZ is 13.75. So if that's 13.75, then we also know that WZ is 13.75. Because they will be congruent if that point lies on the perpendicular bisector, which it does. Okay, then we're going to use that again. It is the perpendicular bisector. So if we know that WZ is 4n minus 13 and YZ is n plus 17, we can find the length of that by setting those two equal to each other, because we know those are the same if it's on the perpendicular bisector. So we're going to do 4n minus 13 equals n plus 17. So we get 3n equals 30. And then n, if we divide by 3, is going to be 10. Okay. So then, but it asks us to find the length of YZ. So I need to plug that in right there. So 10 plus 17. So I know YZ is equal to 27. Okay, and then if we know that this is the perpendicular bisector, again, we're going to assume, so this says that these are both 20.5. Okay, and it tells us that this bottom part down here is 14.8. So we know it's a perpendicular bisector because these two are the same and it's a right angle. So it's a perpendicular line. That distance from the point Z is the same to the two endpoints. So we know that those are congruent. And so we know that, sorry, I'll mark those with 2 because the other one has 1. So if the whole thing is 14.8, we want to find WX, which is half of it. So we're going to do 14.8 and divide it by 2, which is going to give us 7.4. So we know that WX is equal to 7.4. Okay. So we have two more theorems about bisecting, and this time it's not perpendicular bisectors, it's angle bisectors. So if AD bisects this angle here, this angle BAC, then we know, and if this point D, or this line DB, is at a right angle or perpendicular, and DC is perpendicular, then we know that DB, so this blue line right here, and DC are congruent. Okay, but this has to be the bisector, so this part has to be true, and these have to be right angles for the to know that DB and DC are equal. Okay, and then also the converse. So if we know these two are equal, and we know these are perpendicular or right angles, then we can say it's the angle bisector and say that these two angles are congruent. So we can use that and say, do we have enough information here to figure out if QS is the angle bisector of PQR? The answer here is no, because we would need to know that these are right angles, which it does not look like they are. So these two are not marked, and so we would need to know that. So the answer is no, we do not have enough information. If those were right angles, we would. All right, so we can use this information as well. And so we know that BD, it tells us BD bisects angle ABC. So we know these are equal. And DC is 6.9. So that's this part right here. And it asks what DA is. And since we know this is angle bisectors and these are perpendicular, we know DA is also 6.9. Okay. The next one says ray BD bisects ABC, and AD is equal to 3Z plus 7, and CD is 2Z plus 11. And so here we go there, those are equal, so we know these are also going to be equal, so we can set them equal to each other and find what Z is. And then use what we find for Z to find the length of CD. So we're going to do 3Z plus 7 equals 2Z plus 11. And if I subtract 2Z, I get Z, and I subtract 7, I get 4. So we know Z is 4, but it asks us again what the length of CD is, so that's what we need to solve for. So we have 2 times 4 plus 11. Okay, and that is going to give us 8 plus 11, which is 19. So we know that CD, I'm going to write it over here, is equal to 19. Okay, all right. Now we're going to look at this one. Find the measure of angle ABC when AD is equal to 3.2, CD is 3.2, and the measure of DBC is 39 degrees. Okay, well, there's key points here. These are both the same, and these are right angles. So we know this angle here is being bisected. And so if this is 39, then this is also 39. And so we know the measure of angle ABC is both of those 39s added together, which is 78 degrees. Okay. All right, so this next piece is kind of labor intensive. I'm only going to do one example, but you will do the same 4 steps every single time. So we're going to write the equation of a perpendicular bisector on the coordinate plane of the segment with the endpoints of -1, -5, and 3, -1. Okay, so we're going to go way back to chapter 1 when we started finding the midpoint using the midpoint formula. So midpoint is our first step, because that's going to get us bisecting that segment. The midpoint is going to tell us the halfway point, okay? And so that's a huge piece of what we need to do. So we're going to add the x's, so -1 plus 3 divide by 2. And we're going to add the y's, so -5 plus -1 and divide by 2 to find our midpoint. So then we get 2 over 2 and -6 over 2. And so our midpoint is going to be 1, -3. Okay, so this is the midpoint of this segment with those endpoints. Okay, the next thing we need to do is find the slope of this segment, because that's then we're gonna use that slope to find the perpendicular slope. But we need to know the slope of this specific segment to start with. So I'm gonna write, the next thing you want to do is the slope. So m equals -1 minus -5 over 3 minus -1. So that's going to give us 4 over 4. And so our slope here is 1. Okay. The third step is going to be the perpendicular slope. Okay, and so we need that because we're looking for the perpendicular bisector. Okay, so we found the slope. Now we can use this slope to tell us the perpendicular slope, which is going to be the opposite reciprocal of 1, which is -1. Okay. So the last thing we need to do is work to find the equation of that line. So we are going to then plug in two-point slope form. So we're going to use the equation. And we're going to plug into y minus y1 equals m times x minus x1, so point slope form. So I'm going to plug in this midpoint that I found right here and this perpendicular slope into point slope form, because the midpoint is going to be the bisector piece and the perpendicular slope makes it perpendicular. So we have y minus -3 equals -1 times x minus 1. So I can simplify that to y plus 3 equals -1x plus 1, or just -x plus 1, and then subtract 3 from both sides. So my final equation is y equals -x minus 2. Okay, but you're going to go through those 4 steps every single time when you're finding the perpendicular bisector. So first find the midpoint, then find the slope, then find the perpendicular slope, plug the perpendicular slope and the midpoint in to find your equation. Okay, last piece here is a check for understanding. I'm going to scroll up a little bit. I would like you to pause it here. I'm going to have to make these a little smaller, move them up a little. There we go, I'll just do that. So I'm going to have you pause it, and then I will put the work up for this, and you can check your answers. But number 1 is going to be like the one we just did. So first find the midpoint, then find the slope, then find the perpendicular slope, then find the equation for number 1, and then use what we know about angle bisectors and perpendicular bisectors to answers numbers 2 and 3. Okay, so you might want to look back at your notes and then try to answer those. Okay, we are going to go over quickly these answers. So the first thing you want to do for this one is find the midpoint, which ends up being 1, 2 when you plug those 2 points into the midpoint formula. Then the slope, which ends up being 1/3 right here, -1/3, I'm sorry. And then the perpendicular slope is the opposite reciprocal, so it's +3. Then we're going to plug in our perpendicular slope and our point into the equation. So y minus 2 equals 3 times x minus 1. And then simplify to get our final equation of the perpendicular bisector, which is going to be y equals 3x minus 1. Okay. For the next part, we're going to look at this and see that it's angle bisectors, and these are perpendicular, and so they're going to be the same distance from the point. So AD is going to be the same as CD, which is 8.4. And the last one here, we have the perpendicular bisectors. We know it's a bisector because these are marked the same and perpendicular here. So we know the distance from Z to W and Z to Y is the same. So we're going to set them equal, solve it for n, and then plug back in here. So 3 times 9 plus 7 should give you 34. Okay? There's an assignment posted in Classroom, and that is it for today. I hope you have a great day.